A discrete source emits one of five symbols once every millisecond. The symbol probabilities are 1 by 2, 1 by 4, 1 by 8, 1 by 16, and 1 by 16 respectively. Identify the information carried by each symbol and calculate entropy of the source. Solution. The measure of information I of xi of a symbol with probability p of xi is calculated using formula I of xi is log base to p of xi bits. The probability of occurrence of first symbol is p1 is equal to 1 by 2. The information content carried by that symbol is I of x1 is equal to log 1 by p of x1, 1 by 1 by 2. It is log 2 to the base 2, that is 1 bit. Second symbol probability, that is x2, p of x2 probability is 1 by 4. I of x2 information content of the second symbol x2 is I of x2 log 1 by 1 by 4 to the base 2. That is log 2 square to the base 2. That is 2 bits. Symbol x3 probability is 1 by 8. I of x3 is equal to log 1 by 1 by 8 to the base 2. Log 2 cube to the base 2, that is 3 bits. X4, symbol x4, 1 by 16. Log information content of the symbol 4 is I of x4, that is equal to log 1 by 1 by 16 to the base 2. Log 2 power 4 to the base 2, 4 bits. It's 5. 1 by 16 I of x by is log 1 by 1 by 16 to the base 2. Log 2 power 4 to the base 2, that is 4 bits. This is the information content carried by that each and every symbol of the signal source. Entropy of this source. We know that h of x is equal to 5 symbols are there. I is equal to 1 to 5, p of xi into I of xi. P of x1, substitute I value in that expression. P of x1, I of x1, P of x2, I of x2 up to P of x pi, A of x pi. First probability occurrence is symbol occurrence is 1 by 2. I of x1, 1 bit. Second probability occurrence of the second symbol is 1 by 4, 1 by 4 into 2. Third symbol 1 by 8 into 3. Fourth symbol 1 by 16 into 4. Fifth symbol also is equal to 1 by 16 into 4. Therefore, h of x is equal to add these all the terms. 1.875 bits for symbol. Next one, second problem. Consider the following code vectors. C1 is equal to 10010, C2 is equal to 01101, C3 is equal to 11001. Find Hamming distance of between C1 and C2, Hamming distance between C1 and C3, and Hamming distance between C2 and C3. When DCJ is the Hamming distance between code words CI and CJ. CI means C1, C2, C1, C3, C2, C3 like that. So that Hamming distance between two code words C1 and C2, D of C1 and C2 plus D of C2 and C3 is greater than D of C1 and C3. Consider two code words C1 and C2. Hamming distance means the number of positions at which the equal length code words may differ. Equal length C1 and C2 are equal length code words. The number of positions at which they differ. 1 is changed to 0. First 0 is changed to 1. Second position 0 changed to 1. Third 1 is changed to 0. 0 is changed to 1. Differing positions are 5. Therefore, the Hamming distance between C1 and C2 is 5. Next, consider C1 and C3. In C1, 10010, C3 is 11001. Differing positions 1, 2, 3. Hamming D of C1, C3 is different positions, second, fourth, and fifth. Therefore, D of C1 and C3 is equal to 3. Coming to timing distance between two code words, D of C to C3. C2 is equal to 0, 1, 1, 0, 1. C3 is equal to 1, 1, 0, 0, 1. Two positions. This is position 1 and this is position 2. First and third. D of C to C3, two positions. D of C to C3 is equal to 3, 2. Therefore, D of C1, C2 plus D of C2, C3 greater than or equal to D of C1 and C3. D of C1, C2 is 5. D of C2, C3 is 2, that is 7. D of C1 and C3 is equal to 3. Therefore, D of C1, C2, D of C2, C3 is greater than or equal to D of C1, C3. Is greater than only. That is 7 greater than 3 is successfully verified. Next one is the Hamming weight is the number of non-zero elements in a code word. C1, 10010. The number of non-zero elements present in that C1 is 2. Therefore, weight of that code word C1 is 2. The number of non-zero elements present in the code word C2 is 3. Therefore, weight of the code word is weight of the second code word C2 is 3. Weight of the code word C3 is 3. Minimum distance. The minimum distance is the smallest timing distance between any pair of distance code words in the set. Already we know that D of C1, C2 is 5. D of C1, C3 is 2. D of C2, C3 is equal to the minimum distance of all the code words. Consider all the code words. In 5, 3, 2, that is 2. Error detection capability. TD is equal to T D minimum minus 1. 2 minus 1 is equal to 1 error. Error correction capability. TC is equal to D minimum minus 1 by 2. 2 minus 1 by 2, that is 0.5, that is 0 errors.